Hey, Cadence. Slow but fun. Only one that's talking to me so far. Luna. Hi, my angel. How are you? Good to see you, Cadence. All right, we're going to do that drawing, the spinner drawing, in a minute here. So let's remember you have to be present to win. So make sure you respond that you heard me calling you out. All right, so I'm going to share my screen with you guys. All right, share. Hey, Raven. So this is for people that have participated on Friday. So Friday participation is right here. So we will get started on here, see if we got anybody that's here at the time. Make sure that you have your name in here. So this will go for week 6, assignment 1. So, all right, let me get the names set up here. Oops. So I got, all right, where are my names? Week 5 and week 6. Okay, this is week 5. Okay, I'm not sorry, it's not week 5, but assignment week, group 5, 5th hour. All right, everybody's here. Let's see how you guys are doing with this. Okay, James. Oh, no James here yet. Okay, so let's edit this, remove the name. All right, get a winner here. Olivia. No, Olivia, not yet anyway. Okay. Had quite a few people participate on Friday. Cadence, you are here, right? I know you are. Cadence, all right. Where are you? All right, so this is going to go for W6 assignment 1. Okay, so you don't have to do that one. What's it for? Well, you remember you participated last weekend, so last Friday, and I put you in a drawing here, so you got 15 points. So you don't have to do week 6 assignment 1. It's done for you. Big 15 points toward you, 100%. Okay. Yeah, you did it already. Week 6 already. You mean I just posted it? Yeah. All right. Okay. Well, I will find something else. Okay. So did you? I'll find some hole in yours. Okay. Or if we have to, we can wait till week 7. All right. I'll double check. Well, you did a lot of work last night for sure. Okay. Thanks, Cadence. I don't want you to miss out. So if it goes to week 7, I will let you know. Okay. Well, thank you guys for getting in here today. I've got Olivia and Aiden and Devin, Jabari, James, and guys, you guys got to get here on time for this drawing. Come on. All right, so let us take a look at what's going on today. All right, so let's go here. So we're going to be talking about Newton's first law of motion. All right, so Newton's first law of motion, also known as, AKA, the law of inertia. And I don't know if you know what inertia is, but inertia, it's like, it's kind of figured out to be a feeling like where you just can't get started. Or so in scientific terms, it's resistance to change in motion. So it could also be the resistance in wanting to do the work. All right, so it could be that as well. Hey, Ryder, who else did I see come in? All right, let's see. Madison Jones, good to see you, Madison. So in science, okay, what we're looking at to describe the first law, which is really talks about inertia, describe the motion, how it impacts with balance and unbalanced forces, which is a brand new topic for us, balance and unbalanced forces, and then apply it to Newton's law of a projectile, which we won't be talking about too much. If depends on if we have the time. The motion is everywhere in our lives, and Newton's first law explains how things move, how forces work on this movement, and then it's a fundamental in predicting motion. Okay, it describes motion and why things happen the way they do. Okay, we always knew that things have a hard time starting and stopping, but we never gave it a word. They gave it Newton's law of came up with the first to kind of describe it and why it's doing what it's doing. Let's see, who do we get in here? All right, anybody new? Rosa, good to see you. All right, so I can describe a property of matter. So this is a property of matter, it's not a force, called inertia, which causes object to keep moving in a straight line motion or want to stay at rest unless acted by an unbalanced force. And we'll be talking about that in a minute. So inertia is a property of matter. Inertia is an object's resistance into the change in motion. All right, so here is inertia. Let me give you my slide presentation here that kind of show you an example. There are so many examples of inertia, and I used to spend all day when we had time just showing you guys videos on how inertia is so interesting to see. So if I show you this, I'm going to turn my camera off for a minute. Okay, so here is a video of me getting my driver's license, and there is a coin on top. Okay, so we're talking about resistance to change in motion. Now, you might have predicted that the coin will stay on top or the coin will go into the container. Let's do a poll here. Start a poll. Okay, so A, coin moves with card, or B, hi Jana, coin goes stays behind and goes into jar. Or yeah, let's call it a jar. It's easier for me to say jar. So let's see what you said. Let's make some prediction here. A or B, which do you think is going to happen? Right. And again, remember, anytime you make predictions, right, these are poll questions that I use on the next poll, on my next um, review, where I will spin the wheel and give you a free assignment. So again, put your name in the hat here. Okay, it stays. So the coin's gonna go into the jar, or the coin's gonna fly with the card. Which you think's gonna happen? All right, we got 6 out of 19. Thanks, my angel, Rosa, Brooke, Jana, Kimsey, Raven, Ryder. Thanks so much. How about you, Hayden or Elroy? How about you guys going there? Lucas, James, what do you think? Make a prediction here for me. Olivia, Luna. All right, I know it's after lunch and you guys probably overpacked your protein, or you didn't eat it all. Sometimes you guys just don't eat. All right, most of you say it's going to be letter B that's going to move into the jar. Let's see what happens. Yeah, and that's because of inertia. So let's understand what inertia is all about here. Inertia is all about the tendency of an object with mass to resist a change in motion. If I tried that with a very a paper circle, it most likely would go with the card because it doesn't have much mass. So inertia depends on the mass, how much material, how much is inside it. So, and sometimes we think of that when there's more material inside, it does gain some weight, but remember, weight is gravity pulling down on it. Okay, so a reminder, there are only two states: a balanced force, no acceleration, so an object can be moving at constant velocity, or it could be at rest, so it looks like it's stopped, right? Unbalanced forces cause acceleration. All right, so in this question, which rock is easier to move and why? So I can tell you that you're going to, the second thing you're going to say in this one, either the lighter one or the heavier one, all right, is because of its mass, right? So if the lighter one moves quicker or easier to move, it's because of its mass. If it's a heavier one that moves quicker, it's because of its mass, right? So what do you think it is? Lighter one or heavier one? Right, the one on the right. All right, that's great. And then somebody put 3 down. I'm not sure what 3 would do for me. Thanks so much. 4, the left one is the heavier one. The lighter one, because of its has less mass. Who said that? Thanks so much, Brooke. Excellent. I like that. Okay. So we have the lighter one is the one that's going to move easier. Makes sense, kind of think about, but we have to think about it in terms of mass, and we have to think of it in terms of a property of mass that's called inertia. Hi, Jana. All right, so objects with less mass have less inertia. Therefore, it's easier to change its motion. Objects with more mass have more inertia and harder to move. It makes sense if you think about if you've ever had to move something, a wheelbarrow full of topsoil is so much harder to move than a wheelbarrow that's empty, right? Good. She's doing great. She's walking around. Thanks for asking, Jana. All right, so the object at rest stays at rest, and an object in motion stays in motion until unbalanced force. Now, we have a lot of forces on Earth, okay? We have all sorts of things like friction. It's like you kick a ball, you're giving a ball some acceleration, but it slows down right away because it hits the grass and starts to slow down because of friction. Or if you throw something into the air, it slows down because of air resistance. So those are forces that we're talking about. All right, so objects at rest will remain at rest, and they will or accelerate or stay at constant speed. All right, let's pay attention, ladies and gentlemen. Let's get the not so much chatting in the text, okay? So unbalanced forces. So I'm going to show you some of this stuff. Okay, so an object in motion will remain in motion at constant velocity until an unbalanced force acts on it. Okay, so again, like I said, we have air resistance and we have grass, so there's a force right there. Now, inertia is a property of matter, depends on its mass. Okay, so somebody's going to be tackling a football player. Certainly, you get somebody to tackle you. It's harder to move somebody that's is got a lot of weight. You notice that some of the people at the line, the center on are all big people, and they're harder to breeze through, move them out of the way. Okay, so some things like this can happen if you're moving and and stop suddenly. So this is Newton's first law of motion, or called inertia, right? And you can see that he was moving forward, right? Moving forward on the bike. The bike stops. Well, he's going to continue moving forward because he has inertia as well. He is moving as fast as the bike. And again, they don't put seatbelts on bikes, but it would be nice if you could, but it's not a practical idea. So let me take a look. Let's take a look at this real quick. Cancel. I'm going to share this without my screen here. So an object is rest. It stays at rest. That's the first law of motion, right? Because it has a lot of inertia. here we have two people of the same size pushing on this same big block. Okay, so this is considered to be balanced. All right, it's a balanced force and it's at rest. It is not moving. This is at rest. It's not moving. So the same thing here, even though doesn't look like there's any forces attached to it. These are balanced forces, right? Now this is an unbalanced force, right? We're pushing to the left and we're making some acceleration here. Acceleration. Oh, T-I-O-N. This is accelerating to the left. So same way with a soccer ball. It's at rest until something like a foot kicks the soccer ball, and then it'll start moving. The object in motion will stay in motion until affected by the friction of the force, friction of the grass or a net. All right, so let's take a look at what let's look at this in actual video or GIF mode so we can take a look at what happens in this one here. All right, let me share this with you guys. Okay, so let me go here. Let me go escape here. Here we go. All right, so this is not locked in place. So the inertia of the car, it wants to stay at rest. So it rolled right off of the not dump truck. This is a tow truck, right? So that's an example of inertia, right? Object at rest wants to stay at rest unless acted on with a force. So forces are needed to keep objects in motion. I'll keep moving unless something hits me. That's true. If you're out in space, you would go on forever. I'll keep moving continuously in orbit if no unbalanced force acts upon me. So if you get something started in space, it will just continually stay in motion forever. So inertia also says an object in motion will stay in motionless in a straight line unless acted by a net force. So here is a force that stopped the person on not a roller skateboard. Okay, wear your seatbelt. All right, you are moving at the same speed as the car, and if you don't have something to stop you, like a seatbelt, you'll continue moving forward, and that's how tragic accidents have happened. Right, so Newton's law: an object at rest will stay at rest, and an object in motion will stay in motion at a constant speed in the same direction unless an unbalanced force acted on it. Okay, so here are crash test dummies here, right? No seatbelts. So let's do these simple for these questions here quickly, right? See if we get the idea across to you guys. All right, so of these, what property of an object describes the natural tendency to resist an acceleration? Is it weight? Is it unbalanced force? Is it shape? Or is it inertia? What have we been talking about? What are we going to talk about here? Got weight. I got inertia. Thanks, Raven. Thanks, Alexis. Thanks, Jana. Thanks, my angel. Thanks, Alexis. All right, so most of you guys got it. It's inertia, right? Inertia is that property that comes along with mass, the mass of an object, right? The mass of an object determines its inertia. The more mass it have, also it looks bigger many times, or it feels heavier many times, it has more inertia. So what is the tendency here? There are two of them here. So see if you can figure out what the tendency is. What two statements about inertia are true? Inertia is a force. Okay, I can tell you it is not a force. It's not A or B. Okay, it's not a force. It's either inertia is a natural tendency or a property of a stationary object to resist motion, or inertia is a natural tendency of a moving object to resist change in velocity. So those two, the last two are correct. C and D are correct. Those are the properties, not a force. All right. Thanks, Raven. Thanks, my angel. Hayden, good to see you. Olivia, thank you. Rosa, Lucas, Jana, Brooke, thanks so much. All right. Got a lot of participants today. 11 out of 26, almost half. All right. So which of these objects of the following quantities describes the object's tendency to resist the change of motion? Which of the following qualities of an object? So what does it have inside it, so to speak, or property of it that resists the change in motion? Is it its size or volume? Is it its mass, or is it the force exerted by an object? Right? Most of you guys got this right. We got 25 people here and here now. It is the object's mass. Remember, by mass, we mean how much material is in there. Okay. So we are done with this assignment. The notes for today. Thank you guys for participating. But what I really would like you guys to do now, right, is get involved in doing the exit quiz. Okay, there are 5-question exit quiz. Oh, that's okay, Jana. What was taking so long? I just have so much time to get in. I got to get my 30 minutes in. Sometimes I click on them faster than people can put the information in. So let me do this for you guys. So what you want to do, if you go to the modules, and I'll put the link here, but if it doesn't work for you for the link, you might want to ask me. All right, so week 5 as an exit quiz, week 6 has an exit quiz. So it's in the module. It says exit quiz inertial. There are 5 questions in there for you. And I will, this counts as extra credit toward the bonus. Also counts as my poll questions. So I will put people's names in there for the next poll, next spinner poll where I give you guys a free assignment. So here is the assignment here. All right, so here's the link for you guys. All right, so if you can't get in, let me know. So what we're going to do now, okay, so I am going to go over a couple things here. So let's stop the whole questions. Let's stop this questions here. All right, so I'm going to give you guys, so what we're going to do, all right, so I'm going to go, let me get this into a different form here. Yes, so today at the end, last 30 minutes, okay, we're going to do, so in the big blue button, I'm going to give you guys a list of people that missed W5 assignment 1, okay? So I will have a breakout session for that. So I will give you the list in the shared notes. So take a look and see if you are done with that. Okay. If you want to do it on your own, you certainly can. If you're not done with it, I will, you can come to the big blue button and go to the and come to our session. Okay. So you have a lot of things that you could do. Alexis, you have a question for me? Okay, thanks for letting me know. All right, so let me get that for you. Yeah, not sure why it doesn't do that. It's just been giving me trouble lately. Anybody else in the private chat, let me know. Okay, that's 226, 26. All right, here we go. I'll send it to you guys. Copy. Here you are, Alexis. Not sure why that doesn't work. Who else? Anybody else have a trouble with that? Finished that earlier. Thanks so much. All right, thanks. Anybody else having trouble with that? Okay. So the big blue button session